Page 7 of differentiation rules. Number 3a. If this is the function, show that the derivative of the function is this. Okay, so we have a quotient here. The top is going to be u and the bottom is going to be v. So I'm going to write them out here. U is equal to 2, and instead of writing square root of x, I'm going to put x to the 1/2 power. V is equal to 1 minus x. And I'm going to find u dash and v dash. U dash is 2 times 1/2 x to the negative 1/2 power. V dash is negative 1. I'm going to put these into the equation for the quotient rule, which is something like this. So on the bottom, I'm going to put 1 minus x quantity squared, and then I'm going to put 1 minus x here, and u dash multiplied times that. You can see that the 2 and the 1/2 cancel each other out, so we're left with x to the negative 1/2. And then we're going to have minus u, which is 2x to the 1/2, times v, or v dash, which is negative 1. Oop. Okay, so there is our quotient. I'm going to check to make sure it looks like this. Doesn't yet, okay. Looks like they want a square root of x in the bottom, so how about if we factor out a 1 over square root of x out of the top? Now, this is 1 over square root of x, so when I factor it out, I'm just left with the 1 minus x in the left term. The right term doesn't have 1 over square root of x, so when I factor out the 1 over square root of x, I end up with another 1/2 x to the 1/2 here. So like the first x to the 1/2 was already there. When I factor out a 1 over square root of x that's not even there, then I'm left with an additional x to the 1/2 here. And it's a little easier to see if we do it backwards. So if I distribute this, you can see that the first term is going to end up being exactly this first term. When I multiply 1 over square root of x times this, do you see how one of these is going to cancel out with that? And then I'm left with what's here, okay? Okay, and then on the bottom, I have 1 minus x quantity squared. So now that I've confirmed that this factoring out of 1 over square root of x is fine, now I'm just going to rewrite it so that the 1 over square root of x is in the denominator, just like the show that destination. And then now I can combine the two x to the 1/2s together into x to the first, right? And then I can combine these two into one term. It's equal to plus 1x, right? And so now the top's just going to be x plus 1, and the bottom is going to be that weird expression. Okay, so we just made it look like that. All right. For what values of x is the derivative 0? So when is this derivative 0? It's 0 when the top is 0, so that would be when x equals equal to negative 1. For what values of x is the derivative undefined? That would mean whenever the denominator is 0. So one of the possibilities is when 1 minus x is 0, 1 minus x is 0 when x is equal to 1. So x equals 1 is one possibility. The other possibility is if we put anything 0 or below in the square root of x. If we put in 0, the denominator is going to be 0, so that would make it undefined. If we put anything negative in the square root, we would also get something undefined, and the whole thing would be undefined. So if x is less than or equal to 0, so x is equal to 1 or x is less than or equal to 0 would cause the derivative to be undefined. Now that I answered the second question, now I need to go back and look at the first question, because look, I had said that the derivative is going to be 0 when x is equal to negative 1, but here I've said that if x is negative 1, then the entire thing would be undefined. So now I need to get rid of this answer here, right? So actually this derivative is never 0, because the x equals -1 solution doesn't work, right? The x as -1 would make this part equal undefined, so there is nothing which would make this function 0. Okay, that's tricky. 15e, derivatives of exponential functions. From your investigation, write down the function which is its own derivative. That would be e to the x. Using the chain rule, write down the derivative of e to the f of x. So e to the f of x is a function inside of the function, right? In the function e to the u, what if u is like a completely different function? Then when we take the derivative, we would remember this function is its own derivative. So the derivative of e to the x is e to the x. The derivative of e to the f of x would be e to the f of x times the chain rule. So that would be the derivative of e to the f of x being the function inside the function e to the u. Find the gradient function for f of x equal to, okay, so whenever we have a function inside of a function, we just need to multiply by the derivative of that function. So the first step is to rewrite the e to the whatever function exactly as is, because we're not going to do anything to the inside first, and then we just multiply times the derivative of the inside. I think it's easier to do a few problems to understand what to do. So when I take the derivative of e to the 4x, I would get e to the 4x. I just rewrite it exactly as is, and then I follow it up by multiplying by the derivative of 4x, which is 4. So it's 4e to the 4x. Let's do this one. Exponent parentheses -2x is another way of saying e to the -2x. So the derivative of e to the -2x, first you just rewrite the function again, and then you multiply times the derivative of the exponent, -2. So that's equal to -2 e to the -2x. Derivative of 2e to the -x over 2, I'm just going to rewrite that first. I'm going to rewrite it as 2e to the -1/2 x. Okay. So first I just rewrite the 2. Then I'm going to take the derivative of e to the -1/2 x. First step is to just rewrite the function as is, and then I multiply it times the exponent's derivative. So the derivative of -1/2 x is simply -1/2. Now I simplify it. I'm going to put together the 2 and the -1/2. I just get negative. There's my derivative. Derivative of 4e to the x over 2 minus 3e to the -x. I'm just going to write 4e to the x over 2. I'm going to rewrite it as 4e to the 1/2 x. Now I'm going to take the derivative of each one. So first I just rewrite the 4. I rewrite e to the 1/2 x. And then I multiply times the derivative of the exponent. Now this one, I rewrite the coefficient. I rewrite e to the -x. And then I take the derivative of the inside, which would be -1. Now I just simplify. 4 over 2 is equal to 2e to the 1/2 x minus -3 times -1 is plus 3e to the -x. Okay. E to the -x squared. When I take the derivative of this, I just first rewrite the entire function. Then I'm going to multiply times the derivative of the exponent, which would be -2x. So if I rewrote it simplified, it would be like that. Okay, K. So for this one here, I think it's a little bit easier if we distribute the 10 first. So we get 10 plus 10e to the 2x. The derivative of 10 is 0. The derivative of 10e to the 2x would be 10e to the 2x, and then we multiply it times the chain rule of the inside function 2x, which is 2. So it's equal to 20e to the 2x. Derivative of e to the 2x plus 1. First we just rewrite the whole function. Then we multiply times the derivative of the exponent, which would be 2. So it would be 2e to the 2x plus 1. Derivative of e to the 1 minus 2x squared, we just rewrite the whole function, and then we multiply times the derivative of the exponent, -2x. simplify. Okay, so whenever you have e to the function, first thing you do is you just copy everything down, repeat it exactly as is, because the derivative of e to the something is e to the something, right? And whenever you have chain rule, you just copy the inside over again, and then afterwards you take the derivative of what's inside and multiply it at the end, making your chain. Okay. Now they have some trickier ones. Now we have multiplications. So we're going to have to use product rule, right? So this is going to be u, and this is going to be v. Our u is x, our v is e to the x, our u dash is 1, our v dash is e to the x, because the derivative of e to the x is e to the x. So let's do product rule. So product rule says we're going to multiply these two together and these two together. So it would be x e to the x plus e to the x. And let's do c. So for this one, we kind of have a product, right? We have u here and we have v here. So this would be u equals e to the x, u dash equals e to the x, v equals x, and v dash equals 1. So remember, product rule, we're going to put v squared on the bottom, vu dash on top, minus uv dash. So v squared would be x squared on the bottom, x on top, times u dash, which is e to the x, minus u, which is e to the x, times v dash, which is just 1. There we go. X squared e to the 3x. So this is a product. So x squared is u, and e to the 3x is v. So u is equal to x squared. V is equal to e to the 3x. The derivative of u is 2x. The derivative of v is 3e to the 3x. I wrote down e to the 3x, and then I wrote down the derivative of the exponent, which would be 3. And then I do a product rule. So it would be x squared times 3e to the 3x plus 2x times e to the 3x. And so let me simplify that. Okay. And for this next one, this one would be u, and this one would be v. It would be a product again. So u is equal to x to the 1/2. I rewrote square root of x as x to the 1/2. V is equal to e to the negative x. U dash is equal to 1/2 x to the negative 1/2. V dash is equal to e to the negative x times the derivative of the exponent, negative 1. So it's equal to negative e to the negative x. Now let's do product rule. I'm going to multiply x to the 1/2 times negative e to the negative x. Add it to e to the negative x times 1/2 x to the negative 1/2. So that's equal to negative x to the 1/2 e to the negative x plus 1/2 x to the negative 1/2 e to the negative x. Negative 1/2 e to the negative x. Okay. Find the gradient of the tangent to this function at x equals 0, and then this function at x equals natural log of 3. They ask us to check the answers using technology, because if they ask for a derivative at a certain point, like these two, we can do that with second calc dy dx function. Okay? So first thing we're going to do is we're going to find the derivative of this. Of course, we're going to have to use chain rule because we have a function inside of a function. So we take the derivative of the outside, and then we take the derivative, multiply times the derivative of the inside. The derivative of e to the x plus 2 is e to the x. Derivative of 2 is 0, so we just put e to the x, right? So that's the derivative of part A. if we substitute in x equals 0, then that would be 4e to the 0 plus 2 cubed times e to the 0. And remember, e to the 0 is 1, so that would be 1 plus 2 inside the parentheses cubed, so that would be 3 cubed, it would be 27. 27 times 4 is like 108. Okay, and now let's try to confirm that in the calculator. We're going to put the original function into y equals. So I'm going to put parentheses e to the x, right arrow plus 2 to the 4th. Oops. To the 4th. And then I'm going to do second calc dy dx, number 6. And then I'm going to type in 0, enter. Oops. It's still graphing. 0, enter. And it says the derivative is 108. Ah, that's what I got. Perfect. Okay. I don't even see it because it's way off the screen. I can get it in the screen by doing zoom fit, but it didn't care. I could still do the derivative even though I couldn't actually see the graph. Okay, so I'm just going to do zoom fit, see if we can see the graph. We can, but since it's an exponential function, it's going to look like trash anyway. Okay. Okay, so now let's do this one. So I'm going to first rewrite this function as e to the 2x plus 10 to the 1/2 power. And after I find the derivative, I'm going to substitute this value in there. You might say, this looks like a hard problem just from the fact that we're going to use natural logs, but don't be afraid. Okay, and then, so do you see I took the derivative of the outside, so instead of 1/2 power, I put the 1/2 down here and reduce the power to the negative 1/2. Now I'm going to multiply times the derivative of the inside. The derivative of the inside is 2e to the 2x, and the derivative of 10 is 0, so it's just 2e to the 2x. I can cancel these two out. And simplify. E to the 2x times e to the 2x plus 10 to the negative 1/2. Now I'm going to substitute in x equals natural log of 3. If I put in x equals natural log of 3, then I would have e2 to the natural log of 3 times e2 to the natural log of 3 plus 10 to the negative 1/2. And so let's see, e2 to the natural log of 3 is the same thing as e natural log of 3 squared. So that if I simplified that, it would be just 3 squared because the e and the natural log cancel each other out. So I end up with 9. So this also is 9. This is negative 1/2. So it would be 9 times 19 to the negative 1/2, which is equal to 9 over the square root of 19. So let's check that with the calculator. So we'll do, I'm going to type this in here offline. I'll be right back. Okay, so I put it in as e to the 2x plus 10 to the 1/2 power. I graph it. And then I'm just going to do second calc dy dx and type in natural log of 3. Okay, so I do second calc dy dx, which is number 6. And I'm going to type in literally natural log of 3. Enter. And it tells me the answer is 2.06 on the calculator. And I don't know if 9 divided by square root of 19 is the same, but let's check. 9 divided by square root of 19. Yes, it's 2.06. So we've confirmed that the answer is correct. Okay, so that's it for page 7.